Hello friends, welcome to Learner's Planet. Friends, this is our first session for pair of linear equations in two variables. You might have learned about linear equations and variables in your junior classes. In this session, we are going to discuss about what is a pair of linear equation, right? So let's begin the session. Now first of all, I take an example of a linear equation. Here I'll take an example of linear equation with one variable. Suppose I have x plus 6 is equal to 0, right? Here I'm just having one variable, that is x, right? So if x plus 6 is equal to 0, x is equal to minus 6. And x plus 6 is equal to 0 is linear equation with one variable. Now why do we call it as a linear equation? Here the variable is having the power as 1, right? That's x raised to 1, right? So the variable is having the power as 1, that's why it is a linear equation. If the variable is having the power as 2, then it will be a quadratic equation. Okay, so since over here the variable is having the power as 1, we call it as a linear equation. Now these sort of equations will always have just one solution, right? See, x plus 6 is equal to 0, that means x is equal to minus 6. Similarly, if 3x is equal to 2, that means x is equal to 2 by 3, right? Now, if we introduce two variables, the linear equation format will be, for an example, it's ax plus by plus c is equal to 0. Here x and y are variables and a, b, c are constants. And x and y are variables. Right? Now various values of x and y will be there which will satisfy this equation, right? Then we discuss simultaneous linear equation in two variables. Right? Now what's that? Suppose we have a pair of linear equations, maybe a1x plus b1y plus c1 is equal to 0, and the other is a2x plus b2y plus c2 is equal to 0, right? We have a pair of linear equations. Okay, and in both the equations we can see two variables are there, right? So we call it as a system of simultaneous linear equation, right? I take an example over here. Suppose x plus y is equal to 9, x minus y is equal to 5. This is a pair of linear equation. Similarly, we can have more examples. Suppose 3x minus 2y is equal to 7, 5x plus 4y is equal to 9, right? So this is also a system of linear equation, right? So precisely, what is the general form of a linear equation or a system of a linear equation? That is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, right? Here a1, a2, b1, b2, c1 and c2, all of them are real numbers, right? They can have negative or positive values, they can be fraction, they can be irrational numbers, but all of them have to be real numbers, right? Now what is the solution of a system of linear equations? Now friends, it's but obvious that we have two relationships among x and y. Suppose I take an example, x minus y is equal to 5 and x plus y is equal to, suppose maybe 9, right? So I have to choose the values where difference between the two variables is 5 and their addition is 9, right? So I have a set that's x is equal to 7 and y is equal to 2. Here you can see the difference between these two is 5 and their addition is 9, right? So this is the solution of this pair of equations. So precisely what is happening over here, we need to choose the values of variables in such a manner that the values satisfy both the equations, right? And these values are known as solution of the given system of linear equations. Okay? Now suppose I take one more example over here. I have x is equal to 2 and y is equal to 1, and I have to prove that x is equal to 2 and y is equal to 1 is the solution of the equations this and this. Right now I have to prove that x is equal to 2 and y is equal to 1 is the solution of both of them or this system of linear equation, right? Now if x is equal to 2 and y is equal to 1 satisfy both of them, then definitely it will be a solution to the system, right? So what I do is I just put the value of x is equal to 2 and y is equal to 1 in both the equations, right? So in 1, if I put x is equal to 2, I get 3 into 2 minus 2 into 1. So that's 6 minus 2, that's 4, and that is right hand side, right? That's this. Okay, that means x is equal to 2 and y is equal to 1 is satisfying this equation. Now let's check for the other one. That's 2 into 2 plus 1, and that's actually 5, so that's also right hand side. Okay, so x is equal to 2 and y is equal to 1 satisfying both the equations, right? That means it is the solution of this pair of linear equation, right? If the values are not satisfying any of the equation, then it will not be called as the solution of the system. Okay? For example, suppose further I take x is equal to 2 and y is equal to 1, and maybe I am having the equation says 2x plus 7y is 11 and x minus 3y is equal to 5. Now I just have to check whether x is equal to 2 and y is equal to 1 is the solution of this pair or not, right? So what I do, I just take the first equation, I put the value of x as 2 and y is 1 on the left hand side. So it's 2 into 2 plus 7, that's 4 plus 7, that's 11, that's right hand side, right? That means x is equal to 2 and y is equal to 1 is the solution of this equation. Okay, now just check it for the second one. I put x is equal to 2 and y is equal to 1. What I'll get is minus 1, and on the right hand side it's 5, right? So x is equal to 2 and y is equal to 1 is not the solution of this equation. That means it is not the solution of the system, right? If it is not the solution of any one of the equation, then it will not be the solution of the system. Okay, so I have taken both the examples and I am sure you are clear now. Now friends, let's have a quick recap of some basic points. Equations of the form ax plus b is equal to 0 or ax is equal to c is called a linear equation, and that's having just one variable. As we can see, x is the only variable, a and b are constant, and here c is constant and a is also constant, right? Okay, so ax plus b is equal to 0 or ax is equal to c is called a linear equation in one variable, and here variable is x, right? And where a, b, c, here a should not be equal to 0, because in that case the variable will be multiplied to 0, so that it will not form a linear equation, right? So a should not be equal to 0 and a, b, c should be real numbers, right? So ax plus b is equal to 0 or ax is equal to c. Here a should not be equal to 0 and a, b, c should be real numbers, right? So this is what a linear equation in one variable, right? And now whatever the value of x that satisfy over here will be solution of the linear equation. Suppose it is 2x minus 3 is equal to 0. That means x is equal to 3 by 2 is solution of the linear equation. Okay, so this is what linear equation with one variable. Similarly, we have linear equations in two variables. Now we can see there are two equations, 3x plus 4y is equal to 16 and 4x plus 9y is equal to 25. Right? Now we call them as a pair of linear equation in two variables, or we can call them as linear pair also. Okay? We can see the variables as x and y. Here x and y. 3, 4, 16, 4, 9, 25, all of them are constants, right? So this is what the linear equation in two variables. So an equation of the form ax plus by plus c is called a linear equation in two variables. Here variables are x and y, and a should not be equal to 0, b should not be equal to 0, right? Ax plus by plus c is equal to 0. ABC should be real numbers and a and b should not be equal to 0, right? Now what if we talk about the solution, here ax plus by plus c equal to 0, and a, b and c, a and b are not equal to 0, and a, b, c are real numbers, right? So then any pair of values of x and y that satisfy this relationship is called the solution. As we have already discussed, suppose it is 3, or maybe I take x minus y plus 1 is equal to 0. So maybe x is equal to 4, y is equal to 5. That is the solution of this equation, right? So if the given pair satisfy this equation, then it will be solution of this equation. But if the given pair solve or satisfy both the equations, then it will be the solution of the system, right? Suppose x plus y is equal to 10 and x minus y is equal to 8. That means x is equal to 9 and y is equal to 1. That will be the solution of both the equations, right? So I have revised all the concepts. I hope now you will be clear. Now if we discuss about the two lines or the pair of lines, say it is ax plus by plus c, or maybe a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0, right? Now how would they look on a plane, right? There are just three possibilities for two lines on a plane, right? Either the lines will intersect with each other, as we can see over here. This is line L and this is line M. Suppose this is line L and this is line M, right? So they would intersect just at one point, right, as we can see over here, or they would be parallel to each other. That means they are not going to intersect at all in the plane, right? Like this is line L and this is line M. They are not going to intersect anywhere on the plane. That means they are known to be parallel to each other, right? Or the two lines will coincide. That means one line is lying on the other, right? So these are the just three situations for two lines, whether they will meet at one single point, or they will be parallel. That means they are not going to meet at all, or the third situation is the lines will coincide. Okay, so we can I just take one example over here for each one of them. Suppose I have x plus y is equal to maybe 6 and x minus y is equal to 2, right? So in this case, x is equal to 4 and y is equal to 2, right? This is the point when the both the lines are going to meet. That means they are going to just meet at just one single point, right? That's 4 and 2. If you draw this line, x plus y is equal to 6, and if you draw this line, x minus y is equal to 2, they are going to meet at this point, and this will be 4 and 2, right? So what, in other words, we can say that if the lines are intersecting at one point, right, that particular point is known to be the solution of both the, or solution of the system of the equations. So in this case, 4 and 2 is the solution of the system, and in other words, we can say the lines, the two lines x plus y is equal to 6 and x minus y is equal to 2. Both the lines are meeting at one point, and the coordinates of that particular point is 4 and 2, right? Similarly, I have a set of lines that's, suppose 2x minus 3y is equal to 7, and maybe 2x minus 3y is equal to minus 5. This is a set of parallel lines, right? These lines are not going to meet anywhere in the plane, right? So we cannot find any sort of solution for these sort of lines, right? That means no solution, no intersection, or no intersection, that's why there is no solution, and we call them as a parallel lines, right? Similarly, two lines when coincide, suppose one line is x minus y is equal to 5 and other line is 4x minus 4y is equal to 20, right? So these two lines would coincide if you draw this line or if you draw this line, right? The one line will come on the other line, right? Or we can call them as a same line. Why? Because if I take 4 common from this, it's x minus y is equal to 20. So we are getting the same line. Okay. So these are the three cases that we discussed. A single point where the two lines are meeting. When the two lines are parallel, you won't be getting any solution in the plane. That means if you put the values of x and y that satisfy over here, that value, the same value will not satisfy this equation. That means precisely you are not going to get any sort of solution for the lines which are parallel. And the third one is this, when the two lines are coincide with each other, right? Now friends, let's discuss what is consistent pair of equation and what is inconsistent pair of equations, right? We have discussed three examples about two lines. Either the lines are parallel to each other, or they intersect at one point, or they coincide with each other, right? So we have discussed the three situations, right? This is this is this, and this is this, right? So we have the three situations for two line, right? Now when the two lines are intersecting at one point, that means we will be getting one single solution for these two lines, right? In this case, we call the system of equation as consistent, right? And in this case, when we are not getting any sort of solutions, or in other words, we can say the lines are parallel, then we call the system as inconsistent, right? And the third case is when one line coincide with other, we have infinite many solutions, right? And we can call it as a dependent pair of equations, right? So let's discuss this consistent and inconsistent system of equations in detail. Now suppose we have two equations, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So we have one set of equations, right? Here a1, b1, a1 is coefficient of x, a2 is also coefficient of x for this equation. b1 and b2 are coefficients of y, and c1, c2 are constant terms, right? So by looking at the coefficients, we can come to know whether the system of equation is having a unique solution, infinite solutions, or no solutions at all, right? So a1, a2, b1, b2, c1, c2, right? Here, if a1 by a2 is not equal to b1 by b2, right? That means if we divide coefficient of x from this equation by this equation, that's a1 by a2. If it is not equal to b1 by b2, then the lines will be having one solution. This is this condition, right? Or we can say this is consistent system. Right? So the two lines will intersect each other at a unique point, right? And if the second case, when a1 is equal to a2, b1 is equal to b2, I'm sorry, a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the two lines will coincide with each other. It's like this, right? This is one line and the other line will lie on the same line. In that case, the lines will be having, or the system will be having, infinite solution, right? And the third case, when the two lines are parallel. In this case, the system is called to be inconsistent. And if you look at the coefficients, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, right? So these are the three cases for two lines, right? And I give you one or two examples also. Okay, for equation this, a1 by a2 is not equal to b1 by b2. Suppose I take an example of x minus y is 5 and x plus y is equal to 10, right? So in this case, a1 by a2, that is 1 upon 1, is not equal to b1 by b2, that's minus 1 upon 1. Since 1 is not equal to minus 1, right? So a1 by a2 is not equal to b1 by b2. Just by looking at the relationship, we can come to know that this system of equation is consistent and it will give only one solution. That means the two lines will intersect each other at just one point, right? So this is a1 by a2 is not equal to b1 by b2. Now in this case, suppose I have x plus y is equal to 5 and 5x plus 5y is equal to 25. Now in this case, you cannot get a single solution of x and y. You keep on putting the value of x and you'll be keep on getting the value of y, right? Because see, this is x plus y is equal to 5 and this is 5 times x plus y is equal to 5 times 5, right? So this line and this line will coincide with each other. That means we can call this is a unique line. That's why they will be having infinite solutions, right? You keep on putting the value of a and you'll be getting the value of y, right? So this is the situation like this. Okay. And the third one is when the two lines are parallel. Suppose x plus y is equal to 5. Then the other is 2x plus 2y is equal to say 11. In this case, a1 by a2 is 1 by 2. That's equal to b1 by b2. That's also 1 by 2. But that is not equal to c1 by c2. That is 5 by 11. Right? So in this case, the lines will be parallel. So you won't be getting any solutions or any intersection of these two lines. Okay, so you should be clear about the three important points over here. This system of his equation is further inconsistent, right? This system is consistent and this is inconsistent. I hope you are clear. Now friends, we have various methods to get the solution of a system of equation. I take a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, right? So here a1, b1, c1, all of them are real numbers. Now we have various methods to get the solution of the system of equation if they have, right? If the lines are parallel, then we can't get any solution. If there are infinite solutions, so we will not be able to write all the solutions. So here we will talk about a single solution when the two lines are having a unique intersection point, right? So precisely the case is a1 by a2 is not equal to b1 by b2, right? So the first method is graphical method. The second method is substitution method. Third is elimination method, and fourth is cross multiplication method. So we'll be discussing all the methods one by one. In examination, you are asked a question on graphical solution, that is the solution of the system of equations by graphical method. So you need to understand the graphical method thoroughly, and some questions are based on any of these methods plus a word problems is definitely there in your paper, right? So let's discuss all the methods one by one now. Now here we have a graph paper. I just have a quick recap since you might have already learned about the graph in your previous classes. So I will have just a quick recap. This is known as origin. That's O. This is what is x-axis. So I just write x-axis over here. This is what is y-axis. So I just write y over here. Right? So the vertical axis is y-axis, horizontal axis is x-axis, or this axis is known as ordinate, or y coordinate can be known as ordinate and x coordinate can be known as abscissa, right? Now suppose we have the values of x and y as negative also, so we can assume the origin somewhere else also. Suppose this is the center point and this is origin. Right? So if we call origin as O, then this will be O x-axis, this will be O y-axis, this will be O y dash, and this will be O x dash, right? So this is actually first quadrant. I just write over here. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay, I take explain over here. This is origin, that's the coordinate will be considered as 0 0. This is O x-axis, this is O y-axis, this is y dash, and this is x dash, right? This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. In the first quadrant, value of x and y, both of them are positive, right? In the second quadrant, value of x is negative but value of y is positive. In the third quadrant, value of x is negative and value of y is also negative. In the fourth quadrant, value of x is positive but value of y is negative, right? So this is the situation of when we will plot the equations on the graph. Now suppose I have to mark the point 2, 3. It will be in the first quadrant somewhere here. If I have to mark the point minus 2, 3, it will be there in the second quadrant because x is negative, y is positive. If I have to mark minus 2, minus 3, then it will be on the third quadrant where x and y both of them are negative. And if I have to mark 2 and minus 3, it will be fourth quadrant because x is positive, y is negative, right? So when we plot the point, we have to be clear about where x coordinate and y coordinate are positive and negative, right? Now let's try one problem. Suppose I have a set of equation, maybe x minus y is equal to maybe 3 and x plus y is equal to suppose 5, right? So what is the first step? You just take one of the equations. Suppose I take x plus y is equal to 5 and just make one chart like this. Okay, here x and y. You put the value of x and corresponding value of y, just try to get, right? Suppose x is equal to 1, then y will be what? 4. If x is equal to 2, y will be 3. If x is equal to 4, y will be 1. Or if x is equal to maybe minus 1, y will be equal to 6, right? So this is for this. Now similarly for x minus y is equal to 3, we get the same So it's x, it's y. When x is equal to 1, y equal to minus 2. When x is equal to 2, y equal to minus 1. When x is equal to suppose 4, y will be equal to 1, and when x is equal to suppose I take negative value, then y will be equal to, okay, so we got this set and this set. Now we have to draw all these points on this graph paper, right? The first we have to consider this as origin, so it's 0 0. Now next is when x is equal to 1, y is equal to 4, right? So just mark the point. It's 1, 2, 3 and 4, and when x is equal to 1, I'm sorry, so with this is x is equal to 1, y is equal to 4. So this is y is, I just write it over here. Here I have marked the values of x and y. Now when x is equal to 1, y is equal to 4. So x is equal to 1 and y is equal to 4. This is the point, right? Just circle it and you can write it over here. Okay. Next is when x is equal to 2, y is equal to 3. So when x is equal to 2, y is equal to 3. So this is the next point. When x is equal to 4, y is equal to 1. So this is the next point, right? When x is equal to minus 1, y is equal to 6. So when x is equal to minus 1, y is equal to 6, right? Now if you join all these points, that is 1, 2, 3, 4, you'll be getting a line, right? I just draw it. Now you can see I have matched all the points and all the points are coming on this line. So this is the line whose equation is x plus y is equal to 5, right? Similarly, we can draw the line of this line from this equation. So when x is equal to 1, y is equal to minus 2. So when x is equal to 1, y is equal to minus 2. So this is the point. Similarly, when x is equal to 2, y is equal to minus 1. So x is equal to 2 and y is equal to minus 1. Right? Similarly, when x is equal to 4, y is equal to 1. So this is the same point. Then when x is equal to minus 1, y is equal to minus 4. So x is equal to minus 1 and y is equal to minus 4. Okay. Now if I match all these 4 points further, I'll be getting a line. Now we can see the two lines are meeting at this point. Maybe some drawing problem is there, but the two lines are meeting at this point, that we can see from here. That's 4 and 1 is the solution of this equation also, and 4 and 1 is the solution of this equation also. So both the lines are meeting at the point, that's 4, 1, right? So the solution of the system of equation is 4 and 1, right? The value of x is 4 and y is equal to 1. Now there will only be a single solution for this set of equation. Now this line is going in this direction and this line is going in this direction. So they are not going to meet anywhere in the plane, right? So we discussed just one sum for graphical method in this session, and we'll be taking more problems based on graphical methods. We'll be taking even word problems and other methods of solving the system of equations as well in the next session. Do revise this session before you come for the next session. Bye-bye.